Climate Change and Local Responses. This course is brought to you by Gilad James Mystery School. Learn more at giladjames.com. Introduction. Numerical weather prediction, NWP, models are one of the factors contributing to the complex process of providing an accurate weather forecast. A number of global NWP models forecast weather over the whole Earth 7 or more days in advance. These large-scale global models do not provide high-resolution details that can be important for the weather we feel in a particular point, sensible weather. These details are often provided by limited area models, LAMs, that cover a particular area of interest, as will be exemplified in this lecture. The Croatian Meteorological and Hydrological Service, CMHS, uses ALADIN, Aire Limitée Adaptation Dynamique développement International, ALADIN International Team, 1997, limited area model for the operational weather forecast. This lecture describes the operational NWP aspects in CMHS and provides an insight into high-impact weather phenomena that are typical for this region. The quality of NWP model forecast depends on the NWP model that is used to compute the meteorological forecast fields. Model forecast should improve with the improvements in the model equations and parameterizations used to describe the atmospheric processes, Pelkey 2002, Duran 1999, Werner et al. 1997. Another factor is the quality and availability of the measured atmospheric data used as input for the data assimilation procedure that creates the initial conditions for the model forecast. Limited area models also require the lateral boundary conditions data, which are another factor contributing to the quality of the weather forecast. Both initial and lateral boundary conditions are usually taken from a larger scale and lower resolution NWP model covering larger geographical area. The initial conditions can be modified using a local initialization procedure. The operational forecast suite in CMHS uses the initial lateral boundary conditions from the arpège, action de recherche petite échelle grande échelle, http://www.cnrm.meteo.fr, mapdoc/meshmal/guide_arp/arpège.html, Global NWP model run operationally at Meteo, France. Another set of initial and boundary conditions available in CMHS is from the Integrated Forecast System, IFS, http://www.icmwf.in/research/ifstocks/zy36 or 1/index.html, of the European Centre for Medium Range Weather Forecast, ICMWF. The files received from Meteo France and ICMWF do not contain the global model fields covering the whole Earth on the native arpège or IFS grid and model levels. To optimize the data transfer, the model data is interpolated to a limited area Lambert projection grid in a resolution similar to the one of the global model in that area, and it is covering a wider geographical area than the local LAM that uses it. Since ALADIN is a spectral model, initial and boundary conditions contain the meteorological data covering the whole model domain in the form of spectral coefficients, and not only the data on the lateral boundaries. The scheme of the steps taken when making the weather forecast. The number of levels in the vertical is reduced, from 70 in arpège or 91 in IFS to 37 in ALADIN Croatia, since LAM does not have to reach as high in the atmosphere as the global models. The global models have considerably longer forecast range, 10 to 15 days in advance, that require knowledge of the atmospheric processes as high as the stratosphere top and mesosphere. These processes have negligible impact in the 72-hour forecast range used for the operational ALADIN forecast in CMHS. The forecast process, Fig 1, consists of several steps. Collect the measured data representative for the initial forecast time from upper air soundings, surface stations, meteorological satellites, aircraft and radar data. Data quality control, which removes measurements if values are too far from the first guess, removal of observations according to empirical, blacklist and surface observations with too large height difference between model orography and real station height. Establishment of the initial and lateral boundary conditions using data obtained from a larger scale, global, model. The NWP model forecast run that consists of the data assimilation procedure that produces the analysis, best possible approximation of atmospheric initial conditions for the model forecast run. The NWP model forecast. Diagnostics of the derived parameters from the model variables during the forecast run. Post-processing of the model output data. Weather forecasts are time-critical applications. This means that the value of the products quickly degrades with time. In other words, the model forecast run has to finish before a certain time in the day, according to the requirements of the users. The choices of the input data and the model complexity that are used operationally also depend on the hour at which the weather forecast products should be available to the users. It is desired to keep the time span between the data measurements and the availability of the weather forecast as short as possible or within a reasonable interval usually determined by procedures in the forecast office or requirements of the other users. The time required for each forecast step is determined by technical limitations such as the capacity of data transfer to the institution providing the weather forecast as well as the speed of the mainframe computer executing the NWP model software. The amount of data used in points 1 and 2 is limited by the capacity of data storages and speed of the data transfer lines. The complexity of the operational NWP model, as well as the size and grid resolution of the model domain is determined by this time span and the computer power. Arpege model data was the primary choice for the ALADIN operational model input in CMHS since it is available much earlier than the IFS model data, Fig 2. IFS is available later than Arpege because the data assimilation procedure starts later since it waits to assimilate more measured data. On the other hand, Arpege provides two sets of input data, as will be described later. The schedule and timing of the OOUC operational run in August 2011. A considerable effort in the research and development of the ALADIN model has been devoted to the model optimization and various model options with an aim to provide the best possible forecast in the short time using available computer power, YESID, 2011. To improve the 10 meters wind forecast in severe wind situations, like Bora, local name for Bora, wind storms, a procedure that provides a high-resolution forecast of the wind 10 meters above ground has been established. The high-resolution dynamical adaptation, HRDA, of the wind field using a hydrostatic version of the ALADIN model has been introduced to the operational suite soon after the 8 km resolution operational forecast runs have started in 2000, Ivatech Sodden and Tudor, 2004.